Hello everyone, I'm Jonghyun Kim from AI and Mobility Lab. I'm going to review today is a personalized preference learning framework for caching in mobile networks. Let me start with the network model. This paper is about how we can maximize the offloading ratio in caching. Let's start with the network model. This paper, we assume the network system with the centralized contents provider who provides contents to the mobile devices. In this network system, users respectively reflects the preference for their own preferences. So each device has the same mobile cache capacity and the contents that is saved in each device's cache is determined by the preference of each devices. I mean each device. In this network model, we consider the single hop-based device-to-device protocol, and we are gonna I'm gonna explain about um, two preferences type. One is the personalized file preference, and the other is common file preference. A difference between two preferences is the preference type is the one is that common file preference thinks that every device has the same preference, but um, the personalized file preference assume that each device has different preferences. So if you see this network model, it is every time slot it is updated. Um, the parameter uh, to learn this model, we should have parameters, and it is updated every time slot. And the we are talking about the caching, and if I don't have if the device has no file that I want, the one in period time right now, then the device can request to the other device to have to um, send the file that I want, but device has a possible amount of range that it can um, get file from the other cache. Preference learning. Um, we have three parameters. Active level parameter. One is the active level, um, which is the user UI is defined as a possibility that um, user UI is active at requesting content file. It is the active level, and the second one is the personalized file preference, and it is denoted this formulation, and is defined as a conditional probability that user's UI requests file given that the user sends a request. And the third one is the file popularity, and is defined as the probability that file FJ is requested. So we have three parameters, and the difference of these two is if you see this formulation, you can uh, you can recognize that there's difference between these two parameters. The file popularity means that it doesn't consider the preference of each device because all the possibilities same here. But if you see the personalized file preference, it is different. So this um, so there is a possibility range 0 to 1, and it is the conditional probability of UI. So it is denoting the preference of user UI user terminal. Yeah, I mean the user device. So let's see about the cache model. The cache this is a CUI is a vector, which um, which is the set of the CUI comma FJ, and it denotes if the file FJ is inside the um, cache of user device UI. If if the file exists, it is denoted as 1, and if there is no file inside the cache of UI, it is denoted as 0. And CN F is the total matrix of the vector, the cache vector that I just told about. And there is constraints for cache allocation strategy. This S means that the maximum capacity of the file is S in each device. So it is just 1 or 0 that it is the same here. And if the user time is the file number of file and the number of the users. Cache let's see some formulation about the cache model. This whole formulation is about the success of a file by using D2D communication. For so the it's it is it is the average of hit ratio. Yeah, and the second formulation means that the possibility of possibility of that I cannot find my the file I just requested from the arrange D, which is allowed to get file from the other devices. And so it's the lambda. Lambda means that the local cache, the number of uh, number available number of file that um, we can request to local cache, the maximum value of that, and as you see the O average is um, the um, possibility that I cannot find the file from the near devices. So lambda 곱하기 1 lambda times 1 minus O average means that the number of the requested files that I successfully got from. So this is the maximum as the main goal of this paper is to maximize the hit ratio. This is the formulation that I just this representing the maximization of hit ratio. And as you see this circle here, the left one means the personalized file. Left one denotes the personalized fire preference, and the right one denotes the common fire for, preference, and the whole or both formulation means the heat rate maximization of heat ratio, and but uh, these these two variables are so hard to make calculations, so we should um, and this is also an NP-hard problem, so we should translate this NP-hard problem into some modular function. So it is changed because the W here there is two kind of sets, but I just transferred it into W, which is one set. There is possible now in the W set there is also can the in W the whole possible user file matches in the W, and V denotes the user device UI and its preference file FA. So we just transfer the NPR problem into the we should translate NPR's problem, reformulate NPR's problem into the computationally efficient gradient algorithm. So we just did the um, previous step of that, and let's start. Let's see some system architecture. So the learning is iterated for every period with t time slot, and data collection for past t time slot is activated because as we discussed with the CF algorithm, which is the collaborative filtering algorithm, is just it reflects the past information to the previous to the current missing information. So by CF algorithm, we just update the model parameters, and by updating the model parameters, we decide the new caching strategy. And then the contents in the cache is replaced by the decision of the new caching strategy. So total goal of this paper is to lower the traffic by caching. But eventually, the strategy metric. So we should eventually get strategy metrics, and which person is and decide which device prefers which files. So if the files are properly allocated to each users, like seeing the preference of devices, then the hit ratio will be a lot higher. So we should find the hit ratio formulation that maximizes the we should find the strategy that maximizes the hit ratio formulation. So in the process, um, to to update the parameters with the CF algorithm, the to to maximize the hit ratio, there's the paper presents three kind of caching algorithm. So we're gonna look at that a little bit. Let's see the parameters, specific formulation of this um, parameter. The left formulation denotes the how many times the how many files are rated in during the time t, and the second left formulation denotes the 이게 무슨 의미냐면 the second left formulation denotes the in terms of UK the FA is preferred in terms of UK, and this third the right the right formulation denotes the preference of FA for the file FA in the whole set of um, files, contents files. Let's see deeply about the parameter learning. As you see this, the left matrix, there's empty space here, white space. That's because the most of the traffic is formed by the small number of file requests. So only the small number of files are mainly mainly effective to the whole traffic. So we should like um we should infer um the empty space of this empty part. So and we call this predicting the missing rating with user-based collaborative filtering. So about the user-based CF approach, the the so we should first we should know the similarity between the users. There's many kind of way to get the similarity, but we just use the Pearson correlation similarity weight, and this is the formula of the Pearson correlation similarity rate. And for the particular file, there's we get the difference between myself and the other user. So yeah. So mixing about the mixing rating prediction, there is uh, there's biased rating value, and the reason why there is biased rating value in this missing rating prediction, um, it's because we wanted to discuss more about the individuality about for its devices. So some device can be like general, but other device can be tough uh, to give grades. So this paper is mainly about um, the different preference between devices. So we wanted to denote the difference between the devices, difference between the preference of devices. The bias rating value is comes with this reason. So this is the picture that the process of missing rating is filled, and these three it there is this formulation denotes the three kind of parameter that I discussed about, and there is the objective function. So the if you see carefully look at the objective function, the variables are whole variables are composed with the three parameters that we discussed about. So we can complete the objective function that we just um, discussed before. And like discussed before, there are three kind of caching algorithms to maximize the hit ratio. And the first one, I'm gonna start with the first one. Mm, uh, the first one is actually the one with the high complexity, high yeah, high complexity because city actually, because mm, because it's actually optimal algorithm because the reason why it has a high time complexity is that it puts all the possible sets and calculate each, so one-to-one matching. So it calculates every set that is possible. So it has high complexity, and so it is the reason why we should think about the greedy algorithm, because its complexity is too high. Actually, the performance will be a lot better because if we use optimal algorithm, the accuracy will be more higher because it like